Okay. So what we've got today is estimating. Okay, so there are two simple rules to estimating, which is to round every single number to one significant figure and use those rounded numbers to solve the problem. Okay, now this is important because if you're trying to estimate, you have to make sure that you're already good at rounding numbers to one significant figure and you understand that properly. Okay, now I'm going to jump into an example straight away so you can see exactly how it's done. Okay, so we want to estimate 2.55 plus 17.4. Okay, so 2.55 to one significant figure, 2 is our first significant figure, so we bring that down. Okay, so the number after that, we check it. If it's greater than 4, we add 1 to the previous number. And if it's less than 5, we add 0 to the previous number. In this case, it's greater than 4, so we add 1 to the previous number, and we convert the remaining numbers to zeros. And so 2.55 to one significant figure is just 3. Okay? If we do the same for 17.4, our first significant figure is 1. So we check the number right after that. If it's greater than 4, we add 1. If it's less than 5, we add 0. So in this case, 7 is greater than 4. So we add 1. Okay. Convert the remaining numbers to zeros. Okay. So that's just 0, 0, and 1 plus 1 is 2. Okay. So the estimate would then be using the rounded numbers to solve the problem. So 3 plus 20. So our estimated answer is simply 23. Okay? Simply follow the process of rounding all the numbers in the problem to one significant figure and then solving the problem with the rounded numbers. Okay? Okay. Much more complicated, but the rounding process is still the same. 872 to one significant figure first. 8 is the first significant figure, so we bring that down. Okay, we check the number after that, 7. If it's greater than 4, we add 1 to the previous number. If it's less than 5, we add 0. 7 is greater than 4, so we add 1 to the previous number. Okay, and then the remaining numbers we convert to zeros. We complete the addition, and that's 0, 0, 8 plus 1 is 9. So that's 900. Okay. Now, 0.273. Okay. 0 is not a significant figure, so we bring it down and leave it as it is. Our point follows. 2 is our first significant figure. The number after that, we check it. Remember, greater than 4, add 1 to the previous number. Less than 5, add 0 to the previous number. Okay, in this case 7 is greater than 4, so we add 1 to the previous number and we convert the remaining numbers to zeros. So that would just be 0, 0, 2 plus 1, that's 3. Bring our point down, and so that's 0.3. And finally, 32.5. Okay, so first significant figure, 3. We check the number just after that, that's 2. Now if it's greater than 4, we add 1. If it's less than 5, we add 0. In this case, 2 is less than 5, so we add 0 to the previous number, and we convert the remaining numbers to 0. Don't forget the point, that's a 0 as well. So when we complete our addition, point, 3 plus 0, and that's just 3, so that's 30. So to solve the problem, we're going to use the rounded values. So that's 900 over 0.3 times 30. Okay? Now, so that would be 900 over 30 times 0.3. I believe you can do that now, multiplying decimals and all. So that would just be 9. Okay? And 900 divided by 9 is equal to 100. Okay? So that's the estimated answer. Okay? Once again, round all the numbers in the problem to one significant figure, and then use the rounded numbers to solve the problem. Okay, so now another estimate. Pick 7.23 first. 7 is our first significant figure. So we bring down our point as well. So we check 2. If it's greater than 4, we add 1 to the previous number. And if it's less than 5, we add 0. 2 is less than 5, so we add 0 to the previous number, and we convert the remaining numbers to zeros. Okay, complete our addition at 0, 0.7. So, in that case, that's just 7. Okay, next number, 95.3. Bring down our first significant figure, that's 9. We check the number just after it. Using the rules, if it's greater than 4, add plus 1 to the previous number. If it's less than 5, add 0 to the previous number. In this case, it's greater than 4, so we add 1 to the previous number, and we convert the remaining numbers to zeros. Bring down our point, and that's a 0 as well. So when we add, that's 0 point, that's a 0, and 9 plus 1, that's 10. So that's 100.0, which is just 100. Finally, we do the same for 0.046. Zeros like this are not significant figures. We just bring them down, but we don't count them as significant figures. Our first significant figure is 4. So before we close out, we check the number just after that. If it's greater than 4, we add 1 to the previous number. If it's less than 5, we add 0 to the previous number. So 6 is greater than 4, so we add 1 to the previous number and convert the remaining number to 0. When we complete the addition, that's 0. 4 plus 1 is 5. That's 0.0. So 0.046, which is 0.05. Now, to estimate, I can rewrite that I'm trying to solve now 7 times 100 divided by 0.05. Okay? So, that's the same as 700 over 0.05. Now, to do this by hand, you have to convert 0.05 to a fraction. So 0.05 as a fraction, that's going to be 0. The point represents a 1 below the line, and numbers to the left and to the right of the point represent zeros below the line. So I drop the point, and that just becomes 0.05 over 0.100, which is basically 5 over 100. So now we know that what we're really solving is 700 divided by 5 over 100, which is 700 times 100 over 5. So change the sign, flip the second fraction. So this basically results in 100 divided by 5, that's 20, so that's 700 times 20. The final answer is 1430, basically 14,000. Now, the most important thing should be understanding how to round to one significant figure and getting the numbers right here. Okay? The rest can be done by a calculator. Okay? Finally, 11.2, start with that. First significant figure, that's 1. Check the number just after that. If it's greater than 4, add 1 to the previous number. If it's less than 5, add 0 to the previous number. In this case, 1 is less than 5, so we add 0 to the previous number, and then we convert the remaining numbers, bring down our point to just zeros. So when we complete the addition, that's 0.0, and that's just 10. Okay? Now, we have 49.4. Bring down the first significant figure, which is 4. Before we close out, we check the number just after that. If it's greater than 4, we add 1 to the previous number. If it's less than 5, we add 0 to the previous number. In this case, 9 is greater than 4, so we add 1 to the previous number, and we convert the remaining numbers to zeros. Not forgetting our point. Complete the addition, and 0.0, 4 plus 1, that's 5, so that results in 50. Okay, next number, 0.193. 0 is not a significant figure when it's at the start of a number, so we just bring that down, but we don't count it as our first significant figure. We bring our point down as well. Our first significant figure is 1. Okay, Now we check the number just after 1. If it's greater than 4, we add 1 to the previous number. If it's less than 5, we add 0 to the previous number. 9 is greater than 4, we add 1 to the previous number. The remaining numbers we convert to zeros. Complete the addition. That's 0, 0, 1 plus 1, that's 2. Bring down our point, so that's 0.2. Finally, 3.19. So, our first significant figure in this case is 3. Bring down our point. The number just after 3, you need to check it. If it's greater than 4, you add 1 to the previous number. If it's less than 5, you add 0 to the previous number. 1 is less than 5, so I add 0 to the previous number, and I convert the remaining numbers to 0. And so that results in 0, 0, 0.3 plus 0, that's just 3. Okay, so to estimate, I replace all the numbers from the original question with the rounded numbers, so that's 10 plus 50 divided by 0.2 times 3. Okay, now simplifying the top and the bottom, 10 plus 50, that's 60, and 0.2 times 3, that's 0.6. Okay, now converting 0.6 to a fraction, that the point represents a 1 below the line, and any numbers either side of the point represent a 0. So now you just drop the point, that's 0.6 over 0.10, which is basically 6 over 10. Okay, now what we're trying to solve is 60 over 0.6. Okay, now we know 0.6 as a fraction is the same as 6 over 10, so we have 60 divided by 0.6, which we said we know is 6 over 10, and the way to solve this is it's 60, change the sign, flip the second fraction, that's 10 over 6, okay, and so that's equal to 600 over 6. If you simplify the top and the bottom, at the top that would be 60 times 10, at the bottom it would just be 6, okay, or you can write this as a fraction. 60 can be written as 60 over 1, so at the top is 60 times 10, at the bottom 1 times 6, and the final answer 600 divided by 6, that would just give you 100. Okay, so once again, the key thing is rounding all the numbers in the problem to one significant figure. Once you have done that, replace the original numbers with the rounded numbers, and then you can solve using the rounded numbers. Okay, thank you very much. You've been listening to the Math Done, and until next time.